Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. Today we will learn lecture number 2 of a unit motion in a straight line. So let's begin with the lecture number 2. But before we start with the lecture number 2, let's recall what we have done in previous class. We have started with the motion and rest. We have gone through the different categories of motion. It would be a 1D, 2D, 3D and so on. Then we switch to the path length and displacement, and we did a certain numericals based on that. Today let's begin with the uniform motion. Now what is uniform motion? Let's look. What we can say about a uniform motion is, if an object is moving along a straight line and it covers equal distances at equal interval of time, however the small time interval may be, it is said to be in uniform motion along a straight line. Let's look at the situation. Let's say a school van is here. It is this initial position and it travels a 10 meter within a time frame of 1 second. Another 10 meter, another time frame of 1 second. Another 10 meter, another time frame of 1 second. So here all the distance traveled are equal. Time required to travel this amount of distance are equal. So I can say is the school van is in uniform motion. Are you get it? Yes. Okay. Now let's look two quantities. One is the speed, another is the velocity. What is speed? We can say it is a rate at which an object covers a distance. You might know that when and when word rate is coming, not for speed only, at every time up to 11th and 12th of physics, when and when word rate is coming, you must know that a certain quantity is going to be divided by a time. So here distance would be divided by time. So if I take a formula of it, it's a speed is equals to path length divided by time taken. Got it? Okay, what would be the unit of speed? It's a path length in meter, time taken measured in seconds, so it's a meter per second. It is a meter per second. Okay, can you write down the dimensional formula of the speed? Can you write down it? So it should look like this. It is m0 l1 t minus 1. This is the dimensional formula of the speed. Now what is velocity? I should say it is a rate at which an object changes its position in a given direction. You should focus on in a given direction. Again, it is a rate. So when I say it's an velocity, I must write it as a displacement divided by time taken. Unit displacement would be measured in meter, time would be measured in second. So again it is having a dimensional formula of m0 l1 t minus 1. Are you clear with this? I hope these things are clear. Now one more difference. Look at this. Speed is the scalar quantity while velocity is a vector quantity. Now you are well aware that what is scalar, what is vector. When I say vector, we have already discussed in previous class that for any quantity to be vector, it requires to satisfy three primary conditions. Which are they? Can you remember it? Yes. First thing, it must be having a magnitude. Second, it must be having a direction. And third, what is it? Yes, it must follow vector algebra. We will learn about the vector algebra and the vector rules and regulations in next unit, but you must know this. So both are of both are of same category. Both are measuring the speed. While speed, it measures the distance divided by time, while velocity, it measures the displacement divided by time. Speed is the scalar and velocity is the vector. Both are having same dimensional formula. Both are having same dimensions. Are you okay with this? Yes, let's look at one of the numerical of the speed and velocity. Let's look at. Let's look. This is your home. It is an initial position, and this is again your favorite destination. It is a McDonald's. So what the situation is? What the situation is? From your home to McDonald, it is a distance of 2 kilometer. You are living from the home. You are living from the home and reaching to the McDonald's and reaching to the McDonald's, and then you are living from the McDonald's and reaching to the home. So it's a two-way journey. First in this direction, next in this direction. Now, if I have been asked what would be the path length, what your answer would be? Yes, absolutely right. It was from here to here. It's a 2 kilometer one way and 2 kilometer on the another way. So this total distance would be a 4 kilometer. What would be the displacement? Yes, initial position and final position of a person is equal. Initial position and final position of a person is equal. So when initial and final position is equal, displacement must be a zero. So it would be a zero. Yes. Okay. Now, what would be the speed and what would be the velocity? What is speed? The speed is it's a path length divided by time taken. Speed is the path length divided by time taken. So this is 4 divided by 1, which is 4 kilometer per hour. While velocity, while velocity, it is a displacement divided by time taken. Displacement is 0, so velocity is 0. You must write units either meter per second or kilometer per hour. Yes. So speed is the 4 kilometer per hour while the displacement is 0 kilometer per hour or 0 meter per second, you can say it. Are you clear with this? Okay, let's look at certain numeric MCQs. Speed is a yes. Speed is a scalar quantity. Speed is a scalar quantity that you know. Next, velocity. Yes, velocity is a vector quantity that you know. Yes. Now, let's move to the further. When and when we consider speed, we consider a velocity. Basically, we are interested in two kind of categories. What are this? So I can write like this. It's different types of speed. On very primary note, I can divide this in two terms. One is the average speed, another is the instantaneous speed. One is the average speed and another is the instantaneous speed. Now what is average speed? What is average speed? What we can understand by average speed, it is ratio of total distance traveled to total time taken. Now what is instantaneous speed? It is speed of a particle at particular instant of time. Can you differentiate these two things? What is average speed and what is instantaneous speed? Let's take one example. Suppose this is your home and this is McDonald's. These two are at a distance of 10 kilometer. These two are at a distance of 10 kilometer. Let's say you are leaving the home by 4 p.m. in noon. Yes. And you reach to the McD at 4:30 p.m. So if you look at this, you have traveled for the 10 kilometer, you have traveled for the 10 kilometer, and to travel this 10 kilometer you have taken half an hour, this leaving by 4 and reaching at the 4:30. So if anyone say what is your average speed, so you should write it as a 10 kilometer as a distance, and 30 minutes as a time taken. So it's a 20 kilometer per hour, it's a 20 kilometer per hour. While if you are thinking like that, that when you leaving the home, your speed were supposed to be 1 or 2 kilometer per hour. Now you reach to a bigger roads where no traffic were there, as it's a time of noon. So as no traffic were there, so if no traffic were there, you pick up your speed and it should reach to a 30 kilometer per hour, 40 kilometer per hour. Now as traffic signal is coming, now when traffic signal is coming, and fortunately or unfortunately the red light were there, if red light were there, you need to stop. As you need to stop, your speed drops to a 0 kilometer per hour. Now again it's in green light and you started going. When you started going, again you pick up the speed 10 kilometer per hour, 20 kilometer per hour, 30 kilometer per hour. As there are no one in the roads, you reach to the 60 kilometer per hour. Again back again, there is a traffic and your speed drops down, and due to speed drops down, it would be look like 30 kilometer per hour, 20 kilometer per hour, 5 kilometer per hour, and so on. So if you think from this time 4 o'clock to 4:30, you have not traveled with a single speed, you have traveled with so many different speeds. And when you traveled with so many different speeds, you need to calculate this average speed. When we are considering a practical case of our life, we are almost talking about the average speed. Because when certain person is asking what is your speed, we generally decide what is amount of distance that I have been traveled and what amount of time that I have taken, and we just make a division and we give them an answer. So it is the average speed. You need to start your stopwatch when you leave from the source, and you need to stop your stopwatch when you reach the destination. This all timing should be included. Let's say at certain point of time you have been stopped at a fuel station to fill the fuel. Even you need to calculate that time also when you are going to consider, or we are going to calculate the average speed. Even though at that point of time your speed may be 0 kilometer per hour, but you need to calculate it. Are you clear with this? Are you sure? Yes. Okay, let's move on. So average speed, it is the total time taken and total distance traveled, and then I divide total distance with the total time, and the final answer came, that would be an average speed. Now what is instantaneous speed? What is it? Now let's say one of your friend was there. He said you that you are living at 4. Okay, you are reaching a MACD at 4:30. But what was your speed? What was your speed at 4 o'clock, 10 minutes, and 20 seconds? What is your speed at 4 o'clock, 10 minutes, and 20 seconds? Now you are surprised like a lot. That how could I remember that what was my speed at 4 hours and 10 minutes and 20 seconds? Is it possible that anyone remembers that my speed was this, my speed was this, and so on? No, we have absolutely no idea. So when I need to calculate a speed at any particular instant of time, this is particular instant of time, I need to go for the instantaneous speed. Okay, if you want to know what is my speed at this instant, how could I calculate it, or how could I come to know that this is my speed? Tell me, any idea? Do you ride two wheelers or do you ride four wheelers? Both. Okay, great. Do you know speedometer? Yes. Speedometer can give the answer of speedometer can give the answer of instantaneous speed. It always deflects. When you accelerate, it goes to a higher number. When you apply a brake, it goes to a lower number. So speedometer always shows your speed at that instant of time. So this is all about the instantaneous speed. Now what we are supposed to do is we are just going to break this both the speeds into different segments. First, we will begin with the average speed and its numericals, and then on the later section of an units, we are going to cover the instantaneous speed. So first, let's begin with the average speed. Let's move on. First, it's an average speed and average velocity. Now, what is average speed? When we say average speed, it's a measure of total distance covered in a given time. So that is total path length divided by total time taken. What is average velocity? It is a measure of total displacement covered in a given time. It is a total displacement due the total time interval. Okay, what are the units of this people? Average speed and average velocity. Unit of average speed. Look at this. It is a total path length, but ideally it is a path length only when I considered about them as a units or dimensions. So it is meter per second. The dimensions, it's an m0 l1 t minus 1. Yes, you are correct. What is the dimensions and units of the average velocity? Tell me. Write down on your book. It's a meter per second. And average velocity, dimensions of it, it's an m0 l1 t minus 1. Great. So do you remember all the speeds and all the velocities have same dimensions? All the speeds and all the velocities have a same dimensions, whether it would be an average speed or average velocity, or whether it would be an instantaneous speed or instantaneous velocity. So do remember this thing. This will help you. Now let's move to the numerical of average speed and average velocity. Do one thing. Take your book, take a pen, and start doing this. You will find this very easy, and I'm sure you would be able to solve this very easily. So do these things. Take a book, take a pen, and do it quickly. Now let's suppose the data has been a person travels 30 kilometer within 20 minutes and another 40 kilometer within 30 minutes of time. Find out average speed of his journey. Now look at the data. What they have given is a person is there which travels 30 kilometer within 20 minutes and another 40 kilometer within next 30 minutes of time. We need to find out the average speed of his journey. Now what is the average speed? What is average speed? I should say it's an average speed, it's an total distance divided by total time taken. Total distance traveled, this is first, it's a 30 kilometer plus 40 kilometer divided by total time taken. First he has considered 20 minutes, another time it's a 30 minutes, so this is 70 by 50, but this is kilometer per minute. If we need to convert this to certain conventional kind of units, which is a kilometer per hour, which is kilometer per hour. So what I should do is 70 by 50 into 60. Yes, this is kilometer per hour. You can solve this. It says 70 into 6. It is a 420 divided by 5. So it would be an easier, but focus on this. Can you do this? This is master formula of average speed. If it would be an average velocity, if it would be an average velocity, you need to write it as a total displacement divided by total time taken. These are basic formulas of average speed and average velocity. You are always need to remember these things, and they can help you to solve any numerical. They can help you to solve any numerical. Let's look at the next numerical. What they have given. Go through this very quickly. Go through this very quickly. They have given us if a body travels with a velocity of v1 for the first half of the journey and with a velocity v2 for the second half of the journey, then find the average velocity v. So first make a rough sketch of this. Let's say this is total journey. I divide this journey into two sections because they say the first half of the journey. Let's say this distance is x and this another distance is x. This is x and this is x. For this x, time required maybe t1 because I have no idea, and the for another the time required would be a t2. They have given me the velocities, that for this their velocity would be a v1 and for this their velocity would be a v2. So let's begin. What they ask is average velocity. This is average velocity, that should be is equals to total displacement divided by total time taken. Now what is total displacement? The data has given x plus x, this is 2x, while the total time, that is a t1 plus t2, but I have been given only v1 and v2, not time. So what should I do this? What should I do? Let's look. What I can write is average velocity. It is equals to what we are having is 2x divided by t1 plus t2. Yes, it is 2x divided by t1 plus t2. Now I have been given v1. What is it? So I can write like this, it's an x by t1. So according to this I can write like this, t1 should be is equals to x by v1. A same way I have been given v2, which is it? It's an x by t2, and according to this I can write like this, t2 should be is equals to x by v2. Now put up the value. It's a 2x divided by t1. T1 it's x by v1 plus x by v2. So that should be is equals to 2x divided by x into bracket 1 by v1 plus 1 by v2. Now if I take an LCM of this, I would be having average velocity as 2 v1 v2 divided by v1 plus v2. It's an average velocity formula which you should remember. Are you clear? Okay, I would like to write one more generalized relation. Now do you know the question exactly? That they have been asked that their distances are equal, not only half of. Even if they have been asked, let's say this is x, let's say this is x, let's say this is x, and onwards. Look at this. Let's say they have been asked that for first section they have traveled with the v1, for next they have traveled with the v2, for next they have traveled with the v3, and so on. This is vn. Suppose this is the situation is this x, 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 and x. Speeds are v1, v2, v3, and vn. Now if I need to find out the average of this, then it would be an n divided by v average is equals to 1 by v1 plus 1 by v2 plus 1 by v3 up to 1 by vn. You need to remember this. Yes, n is the number of divisions of equal distance. This relation can be applied only at the time when distances are equal. When distances are equal. Yes, so please do remember this, and this will help you. Are you clear with this? Any doubts? Shall we move ahead? Okay, let's look. Next, read the data carefully. What they have been given. They are saying that if a body travels with velocity v1 for first half of the journey time, look at this, read carefully. They are not talking about the distance, they are talking about the time. For the first half of the journey time, and with a velocity v2 for the second half of the journey time, then find the average velocity. So what can I do? Let's look. Let's say this is time t. Again, this is time t. We don't know the distance, so let's write down this as an x1 and write down this as an x2. Here the speed would be a v1 that they have given in data, and here the speed would be given as a v2. This is v1, this is v2. What you need to find out? You need to find out the average velocity, v average. So what I should write is, it's a total displacement divided by total time taken. What is displacement? It's an x1 plus x2. What is total time taken? This is t plus t. It would be a 2t. Now what we require our answer in v1 and v2, because we have not been given x1 and x2. So I need to convert this x1 and x2 in respect of the velocity. How could I do this? Let's look. So v average should be is equals to x1 plus x2 divided by 2t. Now I know that v1 should be is equals to x1 divided by t. So I can write like this, x1 should be is equals to v1 into t. We know this v2 is equals to x2 divided by t. So I can write like this, x2 should be is equals to v2 into t. When I write x1, I should write like this, it's a v1 into t plus x2, it's a v2 into t divided by 2t. If I take a t as a common, if I take t common, then I should write like this is v1 plus v2 divided by 2 into t. This t would be the cancel, this t would be the cancel, and final answer would be v1 plus v2 by t. This is v average. Yes, if I write a generalized term, let's say this is speed v1, this is speed v2, this is speed v3, and this is speed vn. This distances are covered in a same time interval. This distance are covered in same time interval. This is t, this is t, this is t, this is t. If this all are covered within the same interval of time, what I can write is v average should be is equals to v1 plus v2 plus v3 up to vn divide by this divide by n. This is v average. So you are having a two formulas. This is applicable when time is equal, while n is the number of divisions of a journey, n is the number of divisions that you know. So this is applicable. This is applicable when time is equal, and the previous relation, this relation was available, and this relation will help when distance will be equal. Okay, did you write it down? So let's look at the next numerical. Read it quickly. What they have been given is a body moves from A to B. This is A, this is B, with a constant speed of 20 kilometer per hour. Okay, and then from B to A with a constant speed of 30 kilometer per hour. Then the average speed of the car is. What could you do? Think over this. Think over this very carefully. Yes, you might get an idea that here first they have traveled from A to B, then they have traveled from B to A, and they are asking about the average speed. Distance would be the same. This should be x, this should be x. So there are two options. One would be a basic formula, which is a total distance divided by total time. Then you go with the total distance, it is an x plus x. Then you go with the time t1 plus t2, and then you solve this is the 2x, and then t1, the t1 would be is equals to x by v1, and t2 would be equals to x by v2, and solve this is the first approach, which is a standard one. But for a competitive examinations, to do this quickly, you must remember certain short tricks, and that trick has been given in previous slides only. So when distances are equal, you can write that V average should be is equals to 2v1 v2 divided by v1 plus v2. Now this is 2 multiplied by one speed was the 20, another was the 30, divide by 20 plus 30. So that should be is equals to 2 3s are 6, 6 2s are 12. So this is 1200 divide by 50, this 0 gone, and 24 5s are 120. This is 24 kilometer per hour. This is average speed. This is average speed of this journey. Yes. Okay, one more question that comes in my mind is, let's say if question has been changed and they have asked what would be the average velocity. What is your answer? If they have been asked what is the average velocity, what would be your answer? Yes, some of you get a hint. Yes, as average velocity, it is a total displacement divided by total time taken, and displacement is 0. So whatever the time would be, we don't mind. It would be a 0 kilometer per hour. In this situation, it would be a 0 kilometer per hour in this situation. Yes. Yes. Okay, let's move to the next question, and be ready with your book. Go with the data what they have been given. Look at this, what they have given. They have given is a body moves with constant speed of 20 kilometer per hour for half of the time, and then with a constant speed of 30 kilometer per hour for another half of the time. Then the average speed. What could you do? First, a very fundamental approach, it's an V average. This is the total distance divided by total time. Distance will be x1 plus x2. Time would be t plus t, that is 2t, and then I need to replace with the v1t plus v2t divided by 2t, and then put up a value and solve this. Here time is equal, here time is equal. Yes. So, and another short trick, it is the v average. It is the v average that should be given as we have divided our whole journey. We have divided our whole journey into two segments. Look at this. First is the 20 kilometer per hour, the another is the 30 kilometer per hour. So let's say this is 20 kilometer per hour and this 30 kilometer per hour. So this is v1 plus v2 by 2. This would be at 20 plus 30 divided by 2. This should be 50 by 2, that is 25 kilometer per hour. This is 25 kilometer per hour. Got it? Got it? Yes. Are you clear with this? So now I hope you must be able to solve this. Yes, for sure. Okay, let's go through this. A very interesting question. Very, very interesting. Read it very carefully. You would have a fun with this. What they have given is a body moves in a straight line and covers first half of the distance with a speed of 5 meter per second, and the second half in two equal halves with speed 4 meter per second and 3 meter per second respectively. Here they should mention two equal half times with speed 4 meter per second and 3 meter per second respectively. You need to find out the average velocity of the body. If you are not getting this, go through the data one more time. Go through the data. Take your time. What they have given. Try to imagine the situation. Try to make a diagram of it. That what would be the situation. Let's say this is their complete journey that has been divided into two parts. A first part, that is the first half of the distance, has been covered with this 5 meter per second. Let's give them a number. It's an A, this is B, and they have been covered this distance with the speed of 5 meter per second. And next half is divided in two equal time. Here the time would be the equal, even here the time would be the equal. This would be the 4 meter per second and this would be the 3 meter per second. This is what they have given. Now I need to find out the average velocity of the body. How could I do it? Think. So first what I think is that here time are equal, t and t. So if I go with the lower half of the journey, I can write v average of lower half. V average of lower half is v1 plus v2 by 2. So it is a 4 plus 3 by 2, which can be calculated as a 7 by 2 meter per second, and this is the average journey of this lower half. So now if I redraw this, the situation would be something like this. This is A, this is B, this is 5 meter per second, and this is 7 by 2 meter per second. This would be the situation. Now you need to find out the V average. Look at this. A to B, this is distance x, another, this is again distance x. So when you need to calculate V average, you can do like this. It's a 2 v1 v2 divided by v1 plus v2. This is 2 multiplied by 5 multiplied by 7 by 2 divided by 5 plus 7 by 2. Yes, so this 2 would be the gone. 5 sevens are 35 divide by 5 plus 2 10, 10 plus 7, this is 17 into 2. So this would be a 70 divided by 17. meter per second. You would be surprised to know that this is the question of JEE Advanced. Yes, and you did it very smoothly and very easily. Yes, so sometimes it would be unhelpful. Sometimes it would be unhelpful to remember the short tricks. There is no harm in it. There is no harm in it. Yes, can you do it? Okay. So let's move to the next question very quickly. Now let's say, suppose the question is saying that a particle travels for 20 seconds with a speed of 20 meter per second and 10 seconds with a speed of 30 meter per second. Find out. Find out average speed of the journey. Go through the data very quickly. Do it fast. Look at this. For 20 seconds they are traveling with this, and for 10 seconds they are traveling with this 30 meter per second. You need to find out the average speed of the journey. So what here, look at this. Here timing are different. It is of 10 second, it is of 20 seconds, but we can divide 20 seconds such that it look alike a same timing. Let's look. This is 10 seconds, this is 10 seconds on a combined. This is 20 seconds, and the speed would be at 20, this would be at 20, and this is another 10 second. At this time speed would be at 30. Now you need to find out the average speed. Now look at this. This is 10 seconds, this is 10 seconds, this is 10 seconds. This are equal, this are having the same time interval. And when time interval are same, when time interval are same, you can simply write like this: v average should be equals to v1 plus v2 plus v3 divided by total number of segments in which you have divided your journey. Here you have divided into 3 sections, so it is a v1 plus v2 plus v3 by 3. So it is 20 plus 20 40, 40 plus 30 70 by 3. This is 70 by 3 meter per second. Yes, if you go with the normal approach, that is the total distance divide by total time taken, even in this situations answer would be the same, but it might get a longer amount of time as compared to this. I hope you are clear with these things, that there are no harm in remembering certain tricks and techniques. Yes, like to do one more question? Yes, okay, let's go. Let's go with this, but do a quickly. Let's say that they have traveled distance 2x with speed 20 meter per second, and another another, let's say 4x with speed 40 meter per second. Find average speed of journey. How can you do this? Think very quickly. Time is running. Think it. Look at this. Here distance are not the same, but you can create or you can divide this 4x in such a manner that they look alike a same. So you can use consider this situation. This is 2x. Split the 4x into two sections. It is 2x. It is 2x. Yes. Now this is 20. This 4x has been divided into these two sections. It is 40 and 40. Now the distance are equal. Now the distance are equal. What you should do? You need to find out the V average. You need to find out the V average. What was the formula? It is, yes, n divided by V average should be equals to 1 by V1 plus 1 by V2 plus 1 by V3. We have divided our total journey into three segments. So that would be 3 divided by V average should be equals to 1 by 20 plus 1 by 40 plus 1 by 40. This 1 by 40 plus 1 by 40. So this is 3 divided by V average should be equals to 1 by 20 plus 1 by 40 plus 1 by 40. It is a 2 by 40. This is a 1 by 20 only. So this is 1 by 20 plus 1 by 20. This is a 2 by 20. Let's move to the next slide. So this is the situation. 3 divided by V average is equals to, it was the 2 by 20. So while I calculate V average, it is 20 into 3 divided by 2. So this would be 30 meter per second. This is the V average. Yes. What was your answer? Is it the same? Good. Well done. So let's shut it down. What we have done in this class, we have started with the type of motion. What is the uniform motion? Then we have just a short intro of the average speed and velocity and instantaneous speed and velocity. In this class we have done all things about the average speed and velocity. Do one more thing, that please do a practice of questions, at least 30 to 40 questions based on this topic only, average speed and velocity. You will have a mastery on this. Okay, so let's shut it down. Bye bye, take care, thank you, have a good day.